Hello, this is Paul from Facade Tech. In this lecture, we're going to deal with conditional probability for uniform distribution. The last time we did the basic probability, right? And the conditional probability is very similar with that. It's only a little bit of difference. The distribution interval we have a little change. Okay, we can see. But first, what is you remember what is conditional probability, right? We have given information. So our example space has to reduce to the given information, right? So the conditional probability is the same. So what is conditional probability? If I given a uniform random variable, okay, and the conditional distribution is the uniform distribution, and the only difference is the sample space is reduced to given condition. So this is just the definition. You know, it's very basic, right? So from the definition of conditional probability, I give you an example. If x is a random variable follow uniform distribution, and we see it's from 1 to 10. Okay. For example, if x is the waiting time of a school bus, okay, you have to wait between 1 minute to 10 minutes. Okay, like that. However, if I ask you another x, see, this is different. We put a bar here. So I mean you have a given information, given condition, given your waiting time is already less than 5 minutes. What is your waiting time's distribution? You can imagine. Okay, so these results tell us, given your waiting time less than 5 minutes, your given time is still follow uniform distribution. And what is this two limit? Okay, what is the interval? That's changed. So first is less than your value of this should be less. Your waiting time should be less than 5 minutes, right? Because it's already given. Okay, so 5 is given. What is this 1? Why your waiting time should be greater than 1 minute? Because of the original minimum value, right? 1 is the minimum value for your original x. See, original x, your waiting time is greater than 1 minute, less than 10 minutes. So 1 is the minimum. So here is the same because it's still your waiting time. Okay, so here is one small example. Later I have a few examples show you how to determine the condition. If we already determined the conditional distribution, and then the probability is just use this conditional probability distribution. So here is some summary. How to find the conditional probability? Only one. Okay, you have to pay attention. Which type of distribution we need to use? It's not use the original. Why? Because now you deal with the conditional distribution. Okay, so we have to use the conditional distribution. And if we have the distribution, now it's easy. We draw a graph, remember? We draw a diagram. So the first draw conditional probability. Still draw a big rectangle with the area 1. Follow your conditional distribution. And then what to do? Shade the region of your probability. Okay, keep in mind your probability based on your question. And then what you get is still a smaller rectangle, right? The third step, the last step, find the area of the shade of the small rectangle. It's the probability. Still similar. Okay, very, very similar. I'm going to show you 3 examples. Can we look at the first? Still the similar questions we did before. Okay, so if I say the age of a customer at the local store, okay, at the local store follows a uniform distribution, and over the interval is from 15 to 75 years old. But look at it. Find the probability the next customer walks through the door is between, but be sure. Okay, the last time we did that questions stop there. Is between. That's a basic probability, but now it's not a basic. Why? Because it's given. We already have some information about the customer who is younger than 40 years old, but we don't know exactly what is the age, right? So what do we need to do? Be careful. So it's given, so means what? Given younger than. Can you see? This is the given information or given condition. This is a given condition. So be careful. And later we're going to find that the probability is a conditional probability, right? Okay, so first let's go into these questions. We need to determine a random variable. Of course, it's the same, right? So the age, we say this is x. So first, we do the same as before. We set up all the questions into mathematics. So we say x is the random variable, okay? Is the age of this customer, okay? Of this customer. We already have some information. See, we look at it, that's uniform, right? This is a uniform distribution. So from 15 to 17, 5. If we don't have any given information, x, we know the distribution, what it is. So x, we know exactly for uniform distribution from 15 years old to 75 years old. This is the original distribution. Be careful, we don't need to use this distribution because we need to use the what? The conditional distribution, okay? And now let's look at the questions. What the probability, the next one is between given. So I wrote here, so you know what the questions. So now what is the question? The question is this probability. Can you see? The age of the next customer is between 30 and 30 and 45. But don't stop here. Okay, put a small bar. This is a given. Given what? Given the given the age, right? So given is already age. So I think here I missed. Given the customer, okay? Given the customer is younger than this. The customer, it means this x, right, is younger than 45. Is younger than, I change this value, it's not a secretive. Thank you. I change this, okay, so this is 65. We use this value to do the calculation. Can we see? So given x is younger than, is smaller than 65. Okay, then we see what is the probability. Now we have this question, right? So this question is a conditional probability. Definitely we know. This is the given condition. Okay, this is the given condition, right? This is a given. What do we need to do to find that the probability? We need to build a conditional distribution. What is the conditional distribution? As we're going to see, conditional distribution field based on the given condition. If I put it here, this is the most important. Let me going to write it down. Okay, so they are talking about the age, but we have a small bar here, and that means given the condition. Okay, given x less than 65. Okay, here's what this is a conditional distribution. Follow what we said is still follow uniform distribution, right? Okay, now what we need to do is determine these two numbers. Be careful. So this is the most important step. So first I was going to put this number, the maximum, right? See, it is already says it's less than 65. So I'll put the 65 here. Okay, why? Because this is a given. This is already given. Okay, I mean the given the customer is already less than 65 years old. What is here? So we're going to see what is there. This should be. We cannot see information from here, right? But we do see information from here is the probability. That's nothing. We need to look back to here. Can we see another? Is the uniform distribution, the original distribution, where this number, y, this is the minimum number, Okay, so can we see? Means what? The age should be greater than 15 years old, right? From 15 to 70. So here should be put 15 here, 15 years. You know Why we put it here? Because this is the minimum possible value for the age of the customer. Now can you understand? So you has the age has the minimum 15 years, have the maximum 16 because it says younger than 16.5, right? Okay, so everything we need is here. Everything we need is here. This is the most important. Okay, if I put this, what is this? This is a conditional distribution, right? This is a conditional distribution. Conditional distribution. Means what? Now we have the distribution. You know, follow the distribution, we can find out what is the probability, right? So I draw the graph here. Like I'm going to draw the distribution from there. Okay, so everyone you know. And this graph is based on what? Based on conditional distribution. Okay, so first, what is this? A is from here. Don't look at it anywhere. Don't look at the original. Look at your new one. Okay, your conditional distribution, which means that this is a 15, right? So this is a 16.5. Now is normal. Okay, what is this? How tall? Remember we have formula 1 over b minus a. Okay, is 1. Now b is this 65 and the a is 15, and then do calculation 1 out of 50, right? So this is 1 out of 50. See, now we determine the first step, the big rectangle. We determine area is 1, and then now we're going to find that your questions 30 to 45. If I say 30 is here, no problem. And so 45, if I say is here, can we draw? The second is do what? Is highlight the small rectangle, which is corresponding to your probability. Is here. The second step we done. And the last step, what do we need to do? Is find the probability, right? So what the probability, remember? So the probability is the area, okay, of this small. So therefore we can find out what the probability. What we need to do is there, okay, that big probability is the width times the height. So of course, what is the width? Well, we're going to show here. The width is here, okay. The width equals 45 minus 30 equals 15. Good. We have the height. We simply say here, okay. This is the height. The height equals the original, so 1 out of 50. See, we have everything. So now the width is 15, the height is 1 out of 50. So you do calculation is 0.3. What does 0.3 mean? 30% of the chance. Okay, now we answer the question. 30% of the chance or the probability the customer who is younger than 65 years old will between, okay, 30 and 45. What is the probability, the chance? 30%. Okay, so did the first questions, and then we look at the second question. You can find which one is the most important. And this, okay, what I highlighted, this is the most important. For any questions, determine this. Don't use that to draw graph. Use your conditional distribution to draw the graph, and then follow the basic steps. We have basic step 1, 2, and 3, right? Okay. Now look at these questions. It's already we formulate into mathematical questions. So you know what we need to do. See, first look at the question. We have a given condition, right? This is a given condition. Therefore, what? This question is a conditional probability. You know, right? This is a conditional probability. Okay, conditional probability, we need to build the conditional distribution. So what is the conditional distribution up to here? X, of course, we deal with the random variable. However, we have a given information there, given condition. X less than 30. Okay. Remember, the DRN tells us DR follow uniform distribution. However, so we need to determine which two numbers here. Okay, we can see first. Can you look at all the given information? So easy to determine this. Okay, this is already given the maximum. The maximum is 30, right? Should be less than 30. So I put the 30 here, the first step. The second number was the minimum. The minimum, don't look at this. This is the specific questions. You need to look at the distribution. The distributions from here. Can you see? I mean, if this is age, so the minimum age is 20. The minimum age is 20. See, can you put it here? If I say this is a minimum, now we have to use the minimum. Okay, put it here, which is 20. Okay, you done most of the questions. Why? Because now we have a conditional distribution, right? If I highlighted this, you know, this is the most important information we need to use in this question. This is the most important information. Okay, you know, it's called a conditional distribution, right? If I write it here, if conditional distribution. Okay, and then everything. Okay, the graph. Now we're going to deal with the probability by draw a graph, right? A diagram. You know, the diagram based on this, not based on the original. Okay, it's based on this conditional distribution. Okay, now we're going to draw. You know how to draw, right? Okay, the very basic. If I say the A, the minimum, this is a B, the maximum. Now we have, if this is 0, now we have a, what is the top, how high, what is the beginning, what is the end, how to do. So you know, follow this. I know this is A. Don't look at the original, look at the conditional distribution. I put here is 20, this is B, but this is 30, and what is the height? Remember the formula is 1 over B minus A, right? Equals B is 30 minus A 20, and then it's 1 out of 10. Okay, easy. So here is 1 out of 10. Almost. This is the first step. You put a bigger rectangle. The second is highlight your questions. Your question is x less than 25. Where 25, I put 25 here. See, I draw a vertical line. Now is less than. Okay, less than means to the left. However, what the minimum, you know how to determine. The minimum should be equal to 20. And the less than 25 means between 20 and 25, right? Don't go beyond. Okay, go down because no probability there. No chance there. This is the probability. Okay, this is a region. This is a high shade of the region corresponding to the probability. Okay, and the last step is find the area. Area we need what the width. Okay, I put the width is 25 minus 20, which is 5. I need the height. Okay, the height is same as this height. The height is there. Okay, it's 1 out of 10. Okay, now you know what the probability, right? So the probability is this. Okay, the original probability there equals the width times the height. The width is 5. The height is 1 out of 10. So this means 50%. All right, so 0.5. I mean this is a 50% of the chance. Or you can see, and this area, the small area, is 50% of the big area. Okay, it's the same meaning. Okay, this is one more question. Look at this. It's still same. So first look at questions. We have a given condition, right? Given condition means now this is a conditional probability. No problem. Not a normal probability, okay? Conditional probability. So we need to build a conditional distribution. If I put the conditional distribution here. So x is the random variable. Where the given information is there, x greater than 20. Now follow still uniform distribution, but we need to figure out these two numbers. Okay, a little bit of difference from this. So first number we determine the left. Why? Because it says x greater. Don't put a 10 here. Okay, why? Because the given information says x greater than 20. Greater than 20, 20 is the minimum, right? So first, here is given is different from the last question. Okay, so I put here is given. Now what is the maximum? This time we have to look somewhere here. Okay, this is the maximum value. Okay, the random variable cannot go beyond 30, right? So this is the maximum. We put 30. Now you finish most of the question, right? Because you have the conditional distribution. This is the most important, okay, always. This is a conditional distribution. Okay, conditional distribution. Tell yourself, okay, for conditional probability, you need the conditional distribution, and then you have distribution. We can use the graph, right? So how to get the graph from this distribution? I will going to draw graph again. Now it's the same as the last question we did. Okay, the 0 if this is the left, if this is the right. Okay, so now the question, so what is the pointer? What is the pointer for the distribution? What is the tall or the height? Okay, so one by one. So now easy. Okay, what is this? 20. What is that? 30. What is the height? Okay, so we look at it. We put here as 1 over b minus a, right? So 1 over 30 minus 20, 1 over 10. Okay, so still 1 over 10. And then what do we get is 1 over 10 here, right? The first step. What is the second step? Find your questions. And let's look at your questions. Your questions, you can see here is very similar with the before. Okay, so your question is x less than 25. Okay, so I'm going to find it. If here is 25 and then I draw less than 25, so where? It's still the same. Okay, so find it the left. Less than 25 should be greater than 20. So here the left half is your probability, right? So we need to find the area. The third step, what the width? The width is 25 minus 20, we get 5. What the height? The height is same as that 1/10. Now you know what the probability. The probability is this. If the width times the height, the width is 5 and the height is 1 out of 10, so this is a 0.5. 50%. Can we see the left is half, right? Of course, this is a 50% of the total area. Yeah, that's all. Thank you.